Hey everyone, welcome back to my uncles. In our last episode, we saw how to implement machine learning on cloud platform, where we understood the basics of Databricks and Apache Spark. We used Apache Spark to implement the basic data transformation as well as creating our classification machine learning model. If you watched this video where we tried to see how to classify whether a transaction is fraud or not, congratulations. If not, you can watch that video or you can continue with this video and watch that video later on. Regardless of that, in today's video, we are going to talk about the financial transaction dataset. Again, with another analysis on some another cloud platform. If you watched the other videos that I have uploaded so far, they really didn't touched any cloud platform other than Databricks, where we saw how to implement experiment tracking using MLflow and integrate it with DexApp. And also, Databricks provides its own experiment tracking service, which you can test on Databricks platform itself. We saw both of those things, and now we are at the stage where we need to touch any other cloud platform. And so for this video, we are going to create a machine learning model that will help us identify what should be the credit limit set to a card that is assigned to a user. So suppose a new user is coming to the bank and he's asking for a Visa card of type credit. Then we want to set a credit limit for that card. So how we can do that on the basis of our existing card data that we have? So that is what we are going to do in this video. It's a regression analysis problem. It's going to be pretty basic, but what is not going to be basic is that we are going to do all of these things in the everyone's favorite cloud platform, AWS. Now, the reason I've chosen AWS is probably because it's popular, but also because it provides a lot of services and integration possibilities in the future. Note one thing, that AWS is not free, but for this video, it will not cost you more than $2 or $3 or around 300 INR if you are from India. So you can watch this video and you can pretty much do everything that I'm doing and it will not cost you a lot. But still, if you are someone like me, because first time when I heard about AWS, I didn't try to touch that, because from the person I heard about AWS, he was continuously scaring everyone in the class that AWS can cost a lot of money, you have to be careful. And that's just not the full truth. The full truth is that AWS will cost you money because it's a cloud platform. And there are two types of cloud platform. We already talked about Databricks, where we get the community version, which is always going to be free to use. And it will automatically shut its cluster once we create those clusters. So after every 2 hours, the clusters will be automatically terminated. But that is not the case with AWS. AWS will set charges for those things that you are using, and you have to pay that. But this is not like you are not aware of what things you are using. So until or unless you are someone who is completely out of mind or someone who is not regular on these kind of things, so you are like, if you're watching this video right now and then you skip in between and you start watching after 1 month, in that case, I would not recommend you to watch this video for the first. And the second would be, even if you watch this video, make notes. Don't try to create your AWS account or work with me with AWS as this video is proceeding. So the thing is that AWS is not going to cost a lot, as I've told you earlier also, hardly $2 or $3. But if you leave things running, then it might cost you some money to pay, which you have to eventually pay. And in the starting as well, you have to put your card details in the AWS for your account creation. And when I first about AWS, I used my friend's card because I didn't had any Visa or MasterCard that time. I hope you have your card, but if you are in the boat which I was once, it's completely fine. You can take your friend's card who is rich enough to have those Visa and MasterCard, or you can watch this video. And in the future, once you get your own card or maybe someone's card, you can start performing the analysis by your side. Regardless of that, I assume that you are eligible enough to create your card and you are having that potential to watch this video in a period of 3 to 4 days. And also I will tell you, even if you are not watching this video, then how can you save your charges by deleting or terminating the instance that we are going to create. Although we are not going to create instance, but still I will tell you what you need to delete in order to save the charges that may cause because of your mistake or maybe your not proper handling of the cloud platform. So yeah, with that note, let's begin this video. And yeah, we are going to talk about today's main shiner would be Amazon SageMaker. Now, Amazon SageMaker is now different. We are going to talk about Amazon SageMaker AI because Amazon SageMaker is now a wrapper which contains Amazon SageMaker AI, Amazon Bedrock. Now, what is Amazon Bedrock? Amazon Bedrock is for generative AI kind of projects, which we are going to touch in the future for this series itself. And what I'm planning is I'm planning to upload a video around Pydantic AI in the future as well, teaching everyone how to use LangChain and the Pydantic AI to work with the RAG. I'm currently studying LightRag, which is a great tool to be honest, but I will not explain more about that in this video. So yeah, there is a lot of scope that we can do on the AWS SageMaker. But for this video, we are going to only talk about Amazon SageMaker AI, which is a part under this big umbrella, which is Amazon SageMaker. So in Amazon SageMaker AI, we are going to see everything from starting to end, a complete project you can show in your resume as well. But before that, I also want to tell you that why Amazon decided to give the name to the platform or to the service as SageMaker. Now, even I was not aware about this and I was not even able to pronounce this correctly. So one of my great mentor, Mr. Vikas Das, explained me the story about SageMaker and I would love to tell you as well. By the way, Vikas Das is a great MLOps teacher right now on the YouTube. I will also provide his link of the channel in the description. You can watch his videos for MLOps. If you prefer to study in Hindi, his content is just a god level content, which is unmatchable with any other content on the YouTube. Regardless of that, what we are going to see is what is Amazon SageMaker, why we have given this name as SageMaker, or why Amazon have given this name as SageMaker. So earlier when foreigners used to visit India, there are some priests in India. We call it as sadhus over there. So those people were basically the future predictors. So they used to predict the future of the person. So from them, after watching those people, the foreigners decided to call them SageMaker, the future predictors. So they used to call them sagers basically. So from that word sager, Amazon decided to use it because over here on the SageMaker, we are doing the same. We are trying to create the models which predicts the future. So that is why Amazon decided to name the platform as Amazon SageMaker. So yeah, that was it for the introduction part. Now let's look at the dataset. If you are someone who is watching this video series for the first time, you have to watch the dataset analysis. If you are someone who has already watched the data understanding, what is our datasets? If you are someone who knows about the dataset, you can skip this part and you can start from the part where I show you how to create your own, I would say, AWS account, and then starting with the Amazon SageMaker. Since in our previous two videos, we have already discussed about users and cards dataset, but still, I assume that you are someone new. And also for my previous users who watched the first two episodes, I want to make sure that they also understand the dataset completely. And for that, we are going to look at our dataset for the final time, but this time we are going to cover up everything to understand the dataset. So I will start by first explaining you what this dataset is having to offer us. You can scroll down and you can see over here. This is a comprehensive financial dataset, combines transaction records, the customer information, and the card data from the banking institution. Although this card data is not correct, so don't try to use it. Spanning across the 2010s decade. That means it is 10 years old dataset. And one more thing I want to add on to this dataset is a synthetic dataset. That means it was generated as a fake dataset. We can do that in Python. We can generate fake dataset. Apart from that, we have the dataset is designed for multiple analytical purposes, from synthetic fraud detection to customer behavior analysis and expense forecasting. Since we are already working with the first analysis, which is going to be the fraud detection analysis, so we are going to look into that. And then in the upcoming videos, as I have discussed in the starting of this video, that we are going to make the customer behavior analysis, which is basically customer segmentation, as well as some other projects around it with Gen AI as well. Okay, so let's see the 5 files that we have over here. We have the transaction files. Transactions data.csv is going to have 1.33 lakh transaction. That means not 1.33 lakh, 1 crore 33 lakh transaction. It's like 13 million transaction. Okay, so 13 million is not a small number. We are not going to analyze the complete transactions.csv file because again 1.2 gigabytes of file to analyze will take at least half an hour to run the code. And as I've told you earlier, we are going to use Databricks for this video. Running this much size of file on the cloud will obviously take more time, and it's not a reliable case for the video. Although we'll understand this file completely, still what we will do is we will segment this file into 4 card types, that is MasterCard, Visa card, MX card and Discover card. We'll talk about that in this video only, but after some time. For now, let's just look what this file has to offer us. So this is a transactions data file. Over here we have, let me come down. You can see we can select the transactions data.csv. And this file is having the amount, timestamp and the merchant detail. Now over here, merchant ID is something new. So let me show you. We have a ID, which is a unique ID for each transaction in this data set. In total, we have 1 crore 33 lakh transaction, or I would say 13 million transaction. So this is a unique ID for all those transactions in my transactions data.csv file. After that, we have date and time of the transaction. As you can see over here, we have the client ID, the client who is doing our transaction. In total, in our data set, we have 2000 unique clients. So this is the client ID for all those unique users, starting from, I guess, 0 or 1 to 2000 as a client ID. So our client ID will be between 0 to 2000, or like from 1 to 2000, or 0 to 1999. I'm not sure about it, but yeah, it's we have 2000 unique clients in our dataset. So for each client, we have multiple cards. So in total, the number of cards that we have in this dataset, the unique cards, are 6146, and these are my cards ID, which is a unique ID for each card. So in this dataset, we have the transaction ID, the date, and the client who is doing the transaction, and the card ID is the card ID from which he is making the transaction. The amount is the amount he is making in the transaction. Then we have this use chip, which is a value to say whether a transaction was a swipe transaction or a chip transaction or an online transaction. So this is again a categorical variable that we have. We have merchant ID, which is for merchants. Now this is again not a unique ID, but still we don't know the merchant ID. Like we just know the merchant ID. We don't know anything else about the merchant. Although we do know the merchant city and merchant state, but apart from that, we don't know anything else. We have zip as well, which is the zip code of the area where the merchant is living. And then we have the other two variables, which is for the error. You don't have to look at this. Just ignore the error right now. For the MCC code. Now, let me explain you what is the MCC code. All of the card brands like MasterCard, Visa, MX card or Discover card, they are having a unique ID for each type of transaction. Suppose you and your friend are going to a restaurant and your friend pays with his card, and you are going to a restaurant. So while that transaction is being stored at the servers of MasterCard, they will assign a unique ID to the business, and that ID is my MCC code. So to all transactions like restaurants, we are assigning a unique value, which is my MCC code, to that kind of transaction. So all kinds of transaction related to restaurants will have a different MCC code. All kinds of transaction related to a car purchasing or a bike purchasing or a vehicle purchasing will have a different MCC code. Suppose you are going to a healthcare service, over there you used your card, so there it will be a different MCC code. So to each industry or to each service that are possibly available right now, we assign a different MCC code to that, just to track what kind of transaction the users are making. And using this MCC code only, in future we are going to perform the customer segmentation so that we can run the campaign only to those potential users who can take the advantage of that campaign and ultimately generate profit for our brand. Okay, so MCC code is really useful. For this dataset, we have only 188 or 189 unique MCC code. That means the transaction is like the all transactions that we have, 1 crore 33 lakh transactions that we have, are done for 188 unique type of businesses, where the merchandisee is given, the merchant state and city is given, and the zip code is given as well. Yeah, so this was all about the transactions data. Now let's look at this client ID. Client ID is basically the user's data, where I have ID as my client ID. So let's move on to the users data.csv file. Let me select this. To get all the columns available, you just have to do it. I don't know why they have added it, but maybe for a very large data set where we have thousands of columns, they don't want you to see all the columns and load all the columns. So that's why they have probably done it. Kaggle, that was really a nice job, but still not of our use for the dataset having only 14 columns. Still, let's look at this users data.csv file. This will contain the data about our users. In total, in our dataset, which is my financial transactions dataset, in our bank, we have only 2000 unique users. So this ID will be from 0. Okay, so it's from 0 to 1999. So there is total 2000 unique users. We have the current age of the users, which is not updated. But since this dataset is of like 7 years ago, it was last updated. So we'll consider this current age as the current age only for the analysis purpose. We have retirement age, we have birth year, we have birth month, we have gender, we have address, we have latitude, longitude, value, from which we can calculate the exact location of the user. We have per capita income, which is like a family total income. So suppose, let me explain you what is per capita income. Suppose you are living in your family of 5. So you are only earning. So you have a earning of $1 lakh or 1 lakh rupees or maybe any other currency. So you are living in a family of 5. So your per capita income will not be 1 lakh. It will be $20,000. Though your yearly income, which is over here, is going to be equivalent to 1 lakh. So this is what the difference between per capita income and the yearly income, which can be a good predictor for a lot of analysis, which we will consider in the further episodes. We have total debt, which is the debt taken by our user. We have credit score, which is the credit score of our user. And the number of credit card defines to how many unique cards do my user have. So you also can have more than one cards. So in this dataset also, we have 2000 users and they can have multiple cards with them. So now let's talk about cards, because we right now only talked about cards. So you can see this is my client ID and it will work as a foreign key in my transactions dataset. So in my transaction dataset, we have the client ID over here. So foreign key is basically from this client ID, you can access to any detail of the user by coming back to the user's dataset. So let's say for the client ID, here we have 561. So for 561, in this dataset, we can't see what is the current age of this client. But if you go back to the users dataset, over here we can see the current age of the client having the ID as 516, although I can't see it over here. But if you scroll down, you'll get the 516 user. Or we can just arrange it in this ascending order. Not needed, but still, I just want to show the curious users that I have. I'm not gonna scroll till 500 values, guys. Check it by yourself. Okay, so after that, let's talk about the cards dataset. Now, this card dataset is also having a unique ID, which is a unique ID for the card, and the client ID, which is my client over here in the user dataset. This is my ID. So this ID and this client ID are basically the same. Here, my client ID is working as a foreign key, referring to this user's data table. I hope you know the basics of SQL. If not, understand it in a way that over here, I'm not giving all details of user. I'm just giving the user ID of the user. And if you want to check more details about the user, you can basically go to this dataset. And for the specific client ID, you can check the other details. Like for 825, we can see the current age is 53, the retirement age is 66, and so on. So in the cards dataset, we have card brand, card type, which is the debit, credit, or debit prepaid. We have card brands. In total, we have 4 card brands, which is MasterCard, Visa, MX, and Discover. We have unique card number, which is also a unique key because every card is going to have a unique card number. We have expiry date for each card. We have CVV number. Although don't try this, it is not gonna work, guys. I've already tried it to check my luck. Okay, just kidding. So this is a synthetic dataset. That's why it will not work. Okay, so it's not a real dataset. We have hash chip value, which is going to tell whether a card is going to have a chip or not. And you can see Kaggle has already created this pie chart showing that almost 89% of our cards are having chip and other 11% are not having chip. We have number of card issued, which will say that single card was issued for 2 times or for 1 times or for 3 times. So it's like the same card, how many times the same card was issued to the user. So, if the card is expired, we are getting the same card again. Or if the card is stolen, we are getting the same card again. So like that, how many cards were issued? So this user got 2 cards. Some users will get 1 card. Some users will get 4 cards. Depends on the user. You can check the values over here. Then we have the last value as credit limit. Although we missed 3 other values. Don't worry. You just have to click on select all. We have the credit limit, which is the credit limit for each card. I hope you know what is credit limit. And if not, then credit limit is the limit of the card. So without paying, you can basically use that limit as your own money. And of course, you have to pay by the end of the month. If you will not, then you will get a heavy interest on that money. So of course, not recommended to those who are not having a stable income. So yeah, then we have the account open date for the user. Last year PIN changed as well. And then we have cards on dark web. This last value is always false, since you can see over here. So in our previous video, what we did was we basically just dropped this column because it was always false. Still, it's a good column to analyze, but although it's of no use because all the values are false. After that, let's talk about the 2 new files which we never discussed before, which is train fraud labels.json and mcc codes.json. Now you can see that in the transactions data, we have this MCC code. So I have already told you that each code will be used to basically distinguish a different business. So in total, we have, I don't know how many unique values, but we have around 180 unique values. So MCC code over here defines to a business. So this MCC code.json is a JSON file which contains what kind of a business that MCC code is having. And in total, we have 109 items. Okay, so we have only 109 or 108 unique businesses for the analysis in this dataset. So we have only 108 unique MCC codes or 109. We'll check that. So you can see over here for 1711 MCC code, it refers to a business that is related to heating, plumbing, air conditioning, or contractor, like all these contractors. Then for 3000, it's for steelworks. For let's say 3144, it's for floor covering stores. And like that, we have these different unique values. For doctors and physicians, we have 8011. For medical services, we have 8099. And like that, we have unique values over here. For barbers over here, I just saw it right now. Okay, for restaurants, you can see it's 85814. And for barbers, I don't see it, although it's gone. I'm not going to waste my time on that. So like that, this file is basically going to have a dictionary kind of structure where we have unique MCC code, and corresponding to that, we have the business that is having that MCC code. So this is given by the credit card brands. Although in real life, I guess that there will be more MCC codes defined by the card brands like MasterCard and Visa. But for this analysis, we are only going to consider this 108 unique MCC codes. And then we have the last file, which is my train fraud labels.json. It's a very big file again, 159.08 MB. Now, let me tell you what this file is going to have. This file will have only two values. The first one will be my transaction ID, and the second one will be a label as yes or no. The name itself suggests that it will tell me whether a transaction is a fraud transaction or not. So it will be having a binary value as yes or no. In our real transaction files, we had 13 million values. But over here, we are only going to have 8.9 million values. That means we don't know what is going to be the values of whether a transaction is fraud or not for the remaining 40 lakh values or 30 lakh values. I guess 40 lakh values, yeah, somewhat around 40 lakh values. We don't know what that transaction is, like it's a fraud transaction or not. But on the other hand, we have 90 lakh values or around 180.89 lakh values, I would say, 8.9 million values. For that, we know that whether that particular transaction ID is a fraud or not. So this is wrong. We have definitely more than 5736 items in this table, in this JSON file, which we will convert into a CSV file just after understanding this file over here. So we can see we have multiple transaction ID over here, along with a label whether the transaction is a fraud transaction or not. So I guess I've took a lot of your time explaining this data set, but it was really important, guys, because what I feel is once you understand the data set, you explore it by yourself, you get that view now to analyze it in a way that it makes sense. So that's why in real world also, we spend more time understanding the data set than actually making machine learning models to it. Because once you understand what your data set has to offer, then and then only you will be able to apply multiple concepts. So after understanding the MCC code, which was for me also something new, because I have never worked in a bank or a card company. So for me, MCC was something new, like, oh, they are checking what kind of a transaction we are making so that they can send us the ads on basis of what our transactions look like what our transactions are based on. Like we are spending more on food, we are spending more on healthcare. So like that, they can send us the offers or something like that, which we can take use of, and even they can generate more revenue. So overall, I hope you enjoyed having a look at this complete data set.